What up, everybody? You ring, we bring. As we spoke about it when we were looking at our content creation on our social media channels, you guys were asking for more in-depth information regarding the real estate development process. And here we go, episode number 1. All right, like we said, we are going to go through the total development process. It's going to be like a class. Obviously, it's not going to get into the minutiae detail. You're always available to reach out to me. And the reason that we want to speak about this is twofold. One, we want to explain concepts that you perceive aren't available to the regular audience, talking about the way in which you develop real estate. No problem. I'm going to break it down to you. The second thing is we're trying to figure out ways to do it cheaper and faster. So those out there with a lot of experience, we're also going to bring in some of the technologies that make the process go smoother and faster, that are actually changing the game. Now, who am I? We talk about it a bunch of times, but do you know? I'm Eric Brody. Nice to meet you. I'm a builder developer in New York City and also a capital advisor. So what does that mean? Number one, we are builder developers. We're doing a 50-unit project and we're doing another 10-unit project. I've done about 800 units over my last 18 years in New York City, infill development, now doing some stuff in Charlotte as well and outside of urban areas. Number two, during coronavirus, we started a venture capital fund in real estate and technology because it was obvious to us that the game was changing. What we then did with that information is we created a podcast on real estate and technology and then started doing shows on The Real Deal because we realized that content, like you're seeing today, is a form of currency. So we are here to share that data and information from you in a programmatic fashion. Each week, we're going to sit down for 10 minutes and we're going to go over a specific concept. What is that concept? It's going to be the taxonomy of real estate development, how you can categorize it from the beginning to the end. What are we going to predicate it off of? We're going to predicate it off of one of my pro formas. So everything that I'm going to be explaining to you, I use in a daily fashion, a daily process in order to either capitalize, that's Annex Real Estate Partners, or develop. All right, so this is all real world information that we're using in the moment to build buildings. So what would be if it wasn't the first episode? What is the first thing that we want to talk about? There's no deal. There's nothing to do if you are not acquiring real estate. So day one, lesson one, acquisition of real estate. Now, when you're looking at the acquisition of real estate, depending on sort of where you're from and what your background is and how you got into real estate is how you look at it. But for me, my father was a registered architect in the city of New York. What does that mean? That means he was licensed. You meet a lot of people, they say they're architects. Architects in the United States of America have to be licensed by the state. And he was proud that he was able to get that license in his first try because that's like an 8-day, 12-hour test of craziness. But what is the point? The point is, in order to understand acquisition, for me, there's two things that are important. Number one, never forget why we're doing this. We are acquiring real estate. We have to have a business plan in order to increase the value of that real estate. For otherwise, what are we doing if not to add value? Is to, in this game, it's an entrepreneurial spirit and to make money. We want to invest capital. We want to get that money back with a return. Otherwise, we're in a different business. We're still capitalists here. So the first thing is, in the real estate game of acquisition, for me, I was telling you, my father's an architect, would be to understand what can be developed or what is existing on any piece of property. Okay? So step one is, what's your business plan? Step two is you have to underwrite that business plan. So we are acquiring an asset. You have to underwrite that asset or that piece of property or land or existing building or industrial complex. It doesn't matter. You have to understand these square footages. And by the way, I say it a lot. You have to understand. You don't have to watch it. You don't have to pay attention to any of it. You are here voluntarily. So I apologize if I tell you you have to. You don't have to do a thing. But if you do want to learn, step one, acquisition. Got to acquire the asset. And as I said, there are three variables that we've spoken about in the past that are super important. They tie into understanding the last dollar per square foot of whatever we do, acquiring land. In New York and in other major cities, we have something called floor area. Floor area is a zoning definition of a theoretical building envelope. We could break that down. Here's a piece of property. It has length and it has width. The city is giving you a certain amount of density, meaning the ability to build. We call that a building envelope. What could actually fit in a theoretical space is a building envelope. That is called floor area. So let's just say hypothetically we have a 100 by 100 lot, which is 10,000 square feet, and the floor area ratio is 5. That means we can build 50,000 square feet of floor area. So first and foremost, what are you legally allowed to build on any site? Because you're trying to determine the price per square foot for that acquisition to know if you're getting a good deal or a bad deal, okay? So step one in acquiring it is understanding what can be built there, the zoning resolution, the building code, what is existing. You need to know down to the square foot what can be built there. That way you can know and compare it to what you others are purchasing for, so you know if you got a good deal, a bad deal, on-market deal, off-market deal. So the first is to acquire it. So let's say you've identified, and by the way, floor area, gross buildable, net sellable, we'll go into those concepts, but right now we don't have the time. We want to talk about acquisition. Okay, so the first is this cost per square foot, which we've defined as either floor area, gross buildable, or net area. At the end of the day, we're solving for net area. Send me questions. You can ask me about specific things. We'll get into it, but we're only doing 10 minutes, so I can't sit here and explain to you all of the math. But next, you finally found the place. You need to negotiate a purchase price. What are you willing to pay for this asset? But what does that mean in the grand scheme, right? In development, in real estate, it's very important to be Machiavellian, which means we have to look at the end result of what you're doing, understand its total cost so that you can determine what is the profit margin you're willing to accept and bring that back to the acquisition price. So someone saying to you something is $2 million, $3 million, $100 million is irrelevant if you don't know what the total cost that you're going to do, the cost of capital, the cost of construction, and then bring that back to what you are acquiring it. Because they say you make your money on acquisition. And what do they mean by that? Because there's so much of a business plan that has to be executed. It's all about what you originally purchased it for. So to talk about purchase price and say, here's the number that you're acquiring it without understanding what your business plan is a fallacy. So we're going to talk more about some of the things that you have to watch out for when you're purchasing real estate. So first is, in purchasing a piece of property, this is a recorded deed. This is a real transaction, which means you need an attorney. An attorney effectuates that transaction in most municipalities. Sometimes there's title escrow agents and brokers who can do it, but let's assume you need to hire a transactional attorney. Now, I said transactional because every attorney is different. Every attorney specializes in something different. In real estate, we have attorneys for zoning and egress, right? Is the zoning resolution and the interpretation of it, we have lawyers for that. What about if you're going for a variance or you're going for a zoning change? Lawyers for that. Lawyers to interpret city planning resolutions. We have lawyers for that. Lawyers for litigation and license agreements. Lawyers for that. Lawyers for joint venture agreements and operating agreements. So my point being is each type of attorney should specifically understand a purchase and sale agreement. That is a cost that needs to be underwritten. That is a player in the acquisition game. Next, after that, what else do we have? We have something called title insurance. Very important in the United States of America that we totally understand everyone who has owned that asset. We call that the chain of title. Why is that important when we talk about title insurance and title fees? Well, it's simple. If somebody else after you acquired something can claim that they own it, you're in a shitstorm of problems. So something that's extremely important is to have title insurance, because title insurance ensures that the title is clear and defends you against anyone coming after you. FYI, it's one of the reasons why everyone loves to invest in the United States of America, because there's the rule of law. So underwriting your purchase price isn't just a purchase price, as we said. You've got legal fees, and now you've got title insurance. Now there's other fees. There's mortgage recording taxes if you're financing it. There's state taxes. Every municipality is different, and you need to understand what those costs are in addition to the purchase price, okay? We call those, many people call those transaction costs, escrow costs, closing costs. those vary by state to state, municipality to municipality, but you need to make a line item and make sure you've included, because that is in the price of playing this game and paying. Next. In the United States of America, we have different ways of identifying parcels of real estate. In major urban areas, it's called block and lot. And the way that we identify that is with a survey. A survey is defining, when I said before, what is the lot area, the specific area of your piece of property. What else is it showing though? In New York City, which is really important, it shows the inverse of all of the point of entry for your sewer, your water. It shows you the inverts in the street of where you can connect that to your building. Now, what's important about that? Cost one day. So put that aside. I'll get into that. The cost of different pumps, ejector pumps, fire pumps, pressure in the street. But just so you know, a survey says that. What else does a survey tell you? It tells you if your neighbors are encumbering on your property. It also tells you if there's any type of easements on your property, anything that can affect title to the property or value is shown on a survey. And that is a licensed surveyor. That means they have to go to class to learn this game. Anytime someone is licensed, I brought up registered architect in the past, they are the lead agency. You aren't telling them what you see, they're telling you what they see because their name and their license is on the line. So if you want to understand the boundaries of your property and you want it to be the letter of the law, it would be a surveyor that's showing it to you, not you taking out your tape rule or Department of Finance showing you. You want the end result? Always the lead agency, always the surveyor. What else? In America, we have environmental concerns, okay? An environmental concern is so important. You want to know why? One of the main reasons, obviously, for the environment and protecting the surrounding areas, but lenders are liable to you and to the property if there's an environmental issue. They cannot pass that liability onto you, the purchaser. So if you borrow money and there is an environmental issue, the lender, regardless of the paperwork that you signed, is at risk. So they require something called an environmental phase 1. Okay? A phase 1 report is just stating, is anything ever happened here that's an environmental concern? And they do it by historical documentation. Then there's something called the phase 2, which means we got to test this bad boy. And then there's a phase 3, which is called remediating it. Let's assume that it's clean. But if it isn't clean, that is a cost to the project that you have to understand. Is there asbestos abatement, UST tanks? Is there dirty dirt? I don't know. The litany of things that can be out there are out there. Just know you would have to underwrite that risk in your pro forma and your understanding of that asset when you purchase it. So there is an environmental risk and you need to know about it. Then you've got your due diligence costs. What would be some due diligence costs that are important for us real estate developers? Well, a zoning analysis, right? Can I theoretically, as of right, build exactly what I'm saying? Well, another thing that builders really like in their due diligence are borings and test pits. What's a boring? A boring is drilling into the earth to understand the capacity of the geology underneath the ground, because when you transfer the load of this heavy building into the ground, it can't settle. Think Leaning Tower of Pisa, right? So that's a massive cost because foundation design is very expensive when it comes to new construction or adding any weight to an existing structure. Really important, called the boring. Next is called the test pit, and really happens in urban areas. And if you can get this diligent cost, it's amazing. What do you need to know? You need to know the depth of your neighbor's foundation, and I can explain it to you at another time. But that is a due diligence cost. How about an appraisal? Is to the lender and their understanding of either what the existing asset is and what you're going to build has the value, because for them it's a risk-adjusted return. You may be paying $100 million for the site, but they only want to lend you a certain amount. So they want to make sure that they understand what other properties have been trading at, what other assets and other costs are in an appraisal. That is a diligence. And that is a diligence cost, okay? Site inspections, we do it in, single family homes. We do that in land. We do it in buildings, right? You need to walk through that building, especially if you're going to an adaptive reuse an asset. You want to understand the structural capacity. And by the way, you want to understand a zillion other things. This is just what's coming to my mind when thinking about your acquisition. Last thing could be your cost of capital or your ability to borrow money, right? There is a finance cost. When you borrow money, there's a cost to close on that money. They have their own lawyers, legal documents, as well as when you borrow that money, you're paying interest on that. The reason that we're discussing this is When you're acquiring a property, it's not just the purchase price. It's the purchase price plus all the diligence costs plus the finance costs, so that acquiring the land has its own set of rules. And at the end of the day, the real issue is when you acquire the land or a building or whatever it is, you then effectuate your business plan to a date certain in the future to see if there was a return on your capital. So you have to understand the nuance, the small little things of acquisition, because any of those costs, if there was a real environmental issue, if there was a real structural issue, if there was a real clout of title, could put you at a cataclysmic risk. You are taking risk in developing or building or doing any type of real estate, and you must mitigate that risk as much as possible, not only for the lender, to your investors, but first to yourself, right? At the end of the day, you are the responsible party. You need to know more than most people, if not all people, about this asset, the nuance of it. The devil is always in the details as a builder or as a value add or a syndicator or whatever the game may be. You have to pay attention to these things because everyone giving you capital and everyone being a part of that deal is in their own little way, and you have to know about all of it. Now, the last thing that I was stating, which I think is super important, right, is technology. What is technology application to the acquisition process, and why should we be paying attention? Because if technology doesn't cut expenses or allow you to maximize revenue, then what is its value? So let's talk about it in the context of an acquisition. There are products out there that can help you in understanding the zoning and the density. We're seeing it. We're seeing applications of layers of municipality zoning resolutions, lot area of properties, and then automating different densities that can occur on that site. Using AI as well as using rules-based engines, people have grabbed all that information that would help you in your due diligence. That should be able to reduce your diligence costs and give you a more accurate picture of what can be built there, right? That would be huge. What about this? And we're seeing it today. What about if you had demographic data on increasing of rents and the reasons why, right? Because increasing rents is just one variable. And there's a great book called On Strategy by John Gaddis, and I'll give you the synopsis. Multiple variables to an actual result are always more accurate than a single data point. So saying rents are going up over here 8% doesn't mean anything compared to the guy who did a 50-point analysis on it and it comes to the same conclusion. He's probably more accurately correct. So, is there a universe where you can start to learn and see indicators or flags that there are certain areas that are increasing in value and the rents are increasing in value based on multiple variables? And the answer is yes. There's another company out there that does just that, that's using AI and analyzing crime data, demographic statistics, socioeconomics, putting that together and saying this area is increasing 4% over the next year or 5% to justify. That would give you information as to where the location for you to take the risk should be. That is an actual change. Now, what changed in that game though? The major companies at the head of the comet have had data scientists looking at this data for years. The change that's happening in the middle market is that we're starting to get access to that information. Next is title searches, environmental reviews, taking minutes instead of days. And finally, what about negotiations? If large language models have come about to put that contract, understand what your risk is, understand what you should be thinking about into a large language model and giving feedback that you can discuss with your attorney? The answer is, oh yeah, it's happening. So at the end of the day, this was just a smidgen of what we're going to go over in this future podcast, of which we're going to be communicating with you. So we'd love your feedback on what you saw and what was most interesting. If there's any specific subject that we had discussed that you'd like to dive deeper into, we're all about it. This is our new content for you, and it's your feedback that's important. We are experts in this space, and with your way of looking at how we're communicating, we only get sharper. Iron sharpens iron. It's been a pleasure. Peace. Architecture is timeless. Just ask Antonio Gaudi in Barcelona. I can't waste no time. They really are timeless.
I cannot waste no time. I'm really timeless.
All right, peeps, welcome back. Session number 2 of the brand new podcast, breaking down the development pro forma with your man, Eric Brody. All right, so what we did the first time is we talked about acquisition. Now you've acquired the asset. What do? You need to hire your first person on the deal, your first professional, and the first one we're going to talk about on the development pro forma, the architect. So my father was an architect for many, many years and is still an architect but retired. And what my father always used to say when you meet someone who says that they're in the design business or they're an architect was one simple question. Are they an RA? What does RA stand for? It stands for Registered Architect. Anyone can call themselves a designer, but a registered architect is a certain process. And when we are talking and moving forward with architecture, we're talking about the legal definition of a registered architect, not a designer friend of yours, all right? Okay. What is the educational requirement to be considered a registered architect versus an architect? So first and foremost, usually like a 5-year program on your bachelor's. Boom. The next thing you have to do, which is crazy, is an apprenticeship. Just like certain trades out there, which we don't do in America, but architecture is required. 3,740 hours across multiple categories: design, project management, construction, admin at an architectural firm. They call it an AXP, Architectural Experience Program. So imagine that after school, you then all do those hours. Then each state has an exam to be licensed. Why? People's lives are on the line. You are designing to the code, the resolution, the building code, multiple dwelling laws, whatever the municipality has a requirement for. So there is a 6-part exam, 12 hours a day that you have to pass, which is insane. Project management, programming and analysis, design, development, documentation, construction, evaluation, just to be called a licensed architect. And each state has its own rules. So that is what's so crazy about it. So when you're speaking to someone, are they an architect or registered architect? Imagine how important it is to respect an RA and what they actually do. All right. Now, architect back in the day, which is fascinating because the term means something, used to mean master builder. That's not me, that's Latin, that's Greek, right? Chief builder, master builder. In ancient times, okay, and that's why I think it's just so important to understand their role. They were required not just to design, they were the engineers, the planners, and often the contractors that were responsible for building the building. The first building code, all right, because just how relevant this is to what we do today, was the Assyrian code circa 1750 BCE. And if you think I memorized that, you got something else coming. I'm looking at a document telling me that. Okay, so they called it the code. Now check this out, because I quote this all the time. If the builder, the architect on the site collapsed and the owner passed away, the builder should be put to death. Imagine how serious it is, and that's why it's a licensed professional. All right, now, what is the role of the architect in your specific development? So first and foremost is to understand the density. What can you actually build there so that you and I could underwrite it, which we were talking about before. The next is they are the designer. What is their vision for this asset? What's the conceptual design? What should we put there? How many units? Type of units? What are the elevations? What is it that you're actually going to put there? What is the vision of the facade, right? Because you look at a macro thesis that there needs to be an actual project here, but you have to make it so that it works for your return on investment. You need the artist to put pen to paper, technically it's now design and it's probably AI, in order to create that design that would be enticing to your consumer. So first, vision and planning. Then, even more important after that is they have to file with that municipality, which we call technical drawings, and getting the actual permit. In many places, there's something called an expediter, like in New York City, but elsewhere, the architect is required to interpret the code with their design to file to get that actual approval. Now you've got the approval, you're looking to move forward. They're responsible for now coordinating. Now there's other trades and there's other engineers that we'll talk about, but the architect sits there and coordinates all of these drawings to give you a set of drawings, which we would call CDs, construction documents, so that you can actually build the building. Now, the architect, which is also interesting, and I've said it before, you have two agreements, one with the contractor and one with the lead architect when it comes to the simplest paradigm to construction and development. So what are they doing? They interface with you, with the client. Not only do they understand the technicality, not only are they understanding density, not only do they have to understand coordination, they also are the ones interfacing with you as the client. And the last thing is, many contract AIA agreements, which we'll go to in the future as well, Architectural Institute Association of America, something like that, they actually are responsible in the field for signing off and saying that the contractor built as to what their intent was. So they also are included in construction admin, meaning actually building that building. Architectural fees, and remember, this is about the pro forma. We're supposed to underwrite the project correctly when we're initially analyzing to see if we want to build this development or not. So what do? How do you underwrite what an architect is? So what we've always done in the past, which is a placeholder, is a price per square foot, right? They have to design a certain criteria for the building. So what we do in underwriting our pro forma is we take what we believe to be the floor area foot, we apply a cost per square foot, and this is just for the architect. So in New York, that pricing can be anywhere from $6 per square foot. Then you have Starchitects up to $20 per square foot. So it really depends on the asset, what you're trying to build and develop, and the scope of work for that specific architect. That is the line item called architect, and now you know a little bit about it. Number one, they better be a registered architect, and now you understand what they are required to fill out for you in order to execute that project, and we went over exactly what that cost should be. Now, the last part that we always talk about in these quick podcasts is, how is technology changing the design and architectural process? So first and foremost, registered architect, license, stamping your drawing. Technology's not removing that. But what about if I told you the following, and this is how AI is changing the game. Can you upload a data lake? A data lake in this case would be every drawing that ever existed for every asset class, or at least a massive amount of input. Let's just say multiple dwellings in New York City, 50 by 100 lots. Let's say you could get 100,000 buildings and get the full documentation of the architectural of 50 by 100 lots. Could you then ask a AI to basically design the best building, meaning based on which variables, highest return, things that are selling, hit enter, and it will assist you in design? The answer is not yet, but that is coming, because if we can understand AutoCAD drawings and then layer in AI, the AI would be able to tell us what the best design is. Then we could pass that to the architect. Obviously, they have to stamp it. It has to be the code. It has to be the resolution. But imagine what the efficiency could be when you're plugging in 100,000 floor plans to know exactly what the most efficient, highest yielding return plan is. Look out for that in the future. That's your boy. Number two on that pro forma, acquisition. And then the first thing we do, we retain our architect, and they better be registered. Talk to you soon. Peace. Geotechnical engineers, they always go in beast mode.
Beast mode. Go beast mode.
Beast mode in design, beast mode in politics, and beast mode in the field. When they feel comfortable, I know that makes me feel comfortable. And if I look in the eyes and they scared, then I know I better be scared. They keep me safe, they get my building complete, and they're the ones who are the unsung heroes. Geo. Welcome back to Breaking Down the Development Pro Forma with your host, Eric Brody. We're on episode number 3. Episode 1, we talked about an acquisition, how you're going to acquire the asset. Episode 2, we talked about the design and the artist, the architecture. Episode 3, it's time to break it down and go below grade, under the surface. And we're going to talk about the geotechnical engineer, so sit down and pay attention. If you've ever actually developed a building, and I don't mean underwrote, and I don't mean sat in an office, I mean got off your tush, went down to the site, and got into the pit, you know there's no way out of the ground if this person isn't on your team, and that's the geotechnical engineer. They are the unsung heroes of the game. And why are they the unsung heroes of the game? As you learn in Construction 101, there's two things that you can never know when you're in your underwriting, and we're going to talk about that later. Number one, what's behind the wall, unless you probe it and demo it. And number two, what's below the ground. So the unsung heroes, they don't get any awards. There's no Starchitecture as the geotechnical engineer. And the better they are, the more confident they are, and the more experienced they are going to save you in your project. All right, we spoke about it. But what does a geotechnical engineer even do, right? What is a geotechnical engineer? It's an engineer that has to understand geological conditions, the different types of performance of dirt, how water is absorbed, water tables, rock, and how your building, the weight of the building, will interact with the earth so that it doesn't have differential settlement, which is like the Leaning Tower of Pisa. All right, so what are the core responsibilities? We now understand that they understand the below-grade conditions, but what are the core responsibilities? In urban construction, they have two main responsibilities. The first one is supportive excavation. When you're building in deep urban environments, you can't impact the neighbor's property. You can't impact the street. Imagine cars coming by winding up in the hole. So it's called an SOE design, support of excavation design. They need to tell you how you're going to go into the ground before you pour any foundation, have no movement of any of the buildings surrounding you, support everything so that you can bring in your foundation and install it. SOE is number one. The number two most important thing that a geotechnical engineer does is now forget about the design, forget about theory and thesis and hypotheticals. They are on the site monitoring the impact of what you are doing day by day, hour by hour, so that you minimize the impact of anyone around you, the structures around you, the people, the buildings, and the cars. So this is the first type of engineer where it's not just a theoretical math design, although there's probably a lot of math in it. They actually have to be in the field, another general in the field, guiding you through the process, making sure that your neighbors aren't moving, make sure you're installing it appropriately to not impact so that you can pour your foundation. So imagine if underground subsurface conditions can ruin your project, it can delay you months at a time. Who's the unsung hero who gets you out? That's the geo. Now, nowhere is geotechnical engineering more critical than high-density urban environments. And that's why there's a soft spot in my heart. Because when I'm in the ground on a foundation in a high-density urban environment, let me tell you one thing that happens every day: stress and anxiety. Because I can't have waking up and finding out that the other building is in my hole. So this is one of those things that you really have to pay attention to. But in New York, we have something quite unique that a geotechnical engineer has to deal with. We have something called neighbor license agreements, which is fascinating. You would think that your neighbor would want you to be building the building because it would add value to their asset when you're completed. Well, guess what? Not in NYC. We got something called NIMBY, not in my backyard, okay? Not YIMBY, yes, in my backyard. So what NIMBY is the next door neighbor being like, oh, you're gonna build here? Don't touch my building. Now, what's interesting is physics says the better I can actually monitor, touch, feel, and understand your building, the easier it will be for me to install and minimizing risk of your building. But that's not the way it works in New York. You need a neighbor license agreement to touch their foundation. In New York, we have to monitor the neighbor's buildings. How do we do that? We do that through vibration monitoring. You want it to be in the cellar of your neighbor's building. We do that also by crack monitoring, surveying their buildings on the XY axis. Certain buildings can move. The geotechnical engineer actually maintains those data points as to how much a neighbor can move so that there won't be any type of critical structural issues. So when we get this license agreements, it needs to be designed what the impact of your neighbors are going to be. That also is your geotechnical engineer. So now not only are they not just theorists, they're now practical. Now they're politicians because they have to work with your neighbor to tell them how they're going to protect their property. So that is why the geotechnical engineer position is so important, especially in high density urban environments. Now, what do you have to provide a geotechnical engineer? Because as you know, in this game, when we're talking about the development pro forma, we always have to tie it back to cost, right? So what are some of the things that you do? What are some of the inputs that you have to give a geotechnical engineer, which you and I would call due diligence when we're going to acquire an asset? What you would want to do is to go into contract and be able to do certain testing.
You want to do environmental testing, obviously, but what are the testing that matters to a geotechnical engineer? And there's two types of testing that we like to provide. The first one is a boring test. A boring test is drilling down, sampling per certain elevations, the type of dirt, the type of rock, and where the water table actually is. Why? Because when there's a certain density of the dirt, we know the load of the building above it that can be sit on that layer of dirt and not settle, meaning compress. The second thing is a test pit. What's a test pit for? I need to know the depth of my neighbor's foundation. Weights of superstructures and foundation are in a teardrop. That means that I cannot apply a pressure on a neighbor building. I have to be at the same elevation as the pressure of their building. A test pit allows me to see the neighbor's foundation, lets me see the depth of their footing so I can understand my SOE and structural design. So when we're doing our due diligence, there's two costs we look for, and that's borings and test pits. All right, as per our discussion, we always tie back to the development pro forma, but there's a lot of variability in the geotechnical engineering and underwriting it. So what line items do we like to break out so that we can mitigate the risk when we underwrite our project? So first is the cost of the engineer themselves, right? How much is that? Well, that really depends on a square foot number, a lump sum number, the complexity, the amount of neighbors, but usually I will put in somewhere between, I don't know, 50 to 75 G's on a 50 to 100 lot, and then I escalate from there depending on the depth of the foundation that I'm going to do. So first is a line item for your geotechnical engineer. The second thing, as we discussed, is the boring and test pits. So these due diligence items we also have to price. The next one is license agreements, which takes an attorney, and also is a time frame. If I'm going to impact my neighbor, I have to pay monthly for that option to be able to protect them or underpin them. So I put a line item in for that. And then the last thing is the monitoring. We spoke about that. It isn't free to have monitoring 24/7, especially when they're IoT, Internet of Things, and it allows you to monitor at all times to do that vibration and also to do the optical point monitoring for any type of settlement. All right, so those are the types of things. And then obviously if you find groundwater and whatever actually gets impacted below grade, you need to put that into your structural design and your structural costs, but we'll talk about hard costs at another time. So when you break it out, we got design, we got monitoring, we got legal work, we got cost of the license agreement, and then the final is just to have some type of contingency, because most likely, player, you're going to take too long and you're going to be wrong. And that's how we mitigate the risk in underwriting our pro forma for the geotechnical engineer. So if you want to be serious about development and you really want to get into the game, you're going to need to understand the basic idea, construction 101, that you have no clue what's happening below grade. So you need to mitigate that risk by doing a bunch of tests and having the right geotechnical engineer, which is part politician, part engineer, and part in the field practical player who's making decisions on the fly, and you need that experience. You also need to underwrite the categories that we stated. So as I was saying, this person, the unsung hero, the geotechnical engineer, can make or break your development pro forma. So if you're serious about developing, never sleep on the geotechnical engineer. And listen, at the end of the day, if you're serious and you're starting to enjoy these videos, make sure that you like, share, send it to your friends, send it to the people trying to get into construction, development, finance. At the end of the day, we're doing two things: capital advisory and asset management. We want to get you the money for your asset, and we want to assist you in the development process. Again, thanks for coming. Episode 3, that's in the bag, baby. Welcome back. Breaking down the development pro forma, where we dissect, we slice, and we're dicing up every cost and every line item in a development pro forma so that we can mitigate our risk and then execute and make money on those promotes. It is time. All right, in the last episode, we talk about the unsung hero, the man who's got to understand the below grade, the geotech engineer. Today, we're talking about the skeletons in my closet. No, I'm talking about the skeleton that holds up your building. And who's responsible for that? None other than the structural engineer. Now remember, I'm always a stickler on licenses. That's a PE, professional engineer. They got schooling, they got tests, and they licensed by the state. So I'm talking about the structural, that one who's responsible. It's not all mathematics. They actually got to take our building from below the ground and get that bad boy up. Episode number 4, the structural engineer. All right, so what is the structural engineer's responsibility, right? They are, I keep saying it, the structural system of the building, but what does that really mean? We got columns, we got beams, we got slabs, we got outside walls and interior walls. Everything that holds that building up and transfers the load above grade back into the ground without it settling differentially, which we'll get into. All right, so why does that matter? Why are we talking about the load above grade and then transferring that into the ground? And that's because the earth below, which we talked about before with our borings and test pits, is irregular. It's got different pockets of different things that are occurring. Maybe it's got clay over here, it's got rock over there, right? But what could happen if it's got different clay, it's got different sand, it's got different fill? What does that really mean? That means that the bearing capacity, its ability to bear the weight of above grade changes, and it's different, right? And you want a uniform slab. Why? If one cracks, you got some problems. Think Leaning Tower of Pisa, right? Which is called uneven settlement. So we don't want cracking, we don't want leaning, and we certainly don't want any type of structural failure. So the structural engineer's job is to make sure that the building settles evenly, transferring the loads back and forth throughout that asset down to the actual footings, and that it was within tolerance, that it can accept that limit, and your building is flat, level, and everybody's happy. Now, what I said sounded kind of simple, right? Little math, little understanding below grade, and boom. Now let's add a little complexity to that little equation that we were talking about. So maybe you're in a stadium. Maybe you don't want columns in the retail space. Maybe you got a floating cantilever that you got to go over the buildings because you bought the air rights, but you can't drive columns straight down. Maybe it's a rooftop pool. Who knows? But all of these design changes affect how the forces impact the existing structures that we were talking about. The slabs, the columns, the beams, right? Okay. So that means that sometimes you got to use different structures, moment frames, post-tension concrete, creative use of materials to support long spans and unconventional layouts. And that's what the beauty is of a building. Without those things, it wouldn't be interesting, but the structural engineer has to take that information and then design for it. Now, they also have to do it within the building code. We talk about it all the time, within budget, right? And then without over-engineering something. Now, the question is why? What are we so concerned about? Because just because you can design a structure that's feasible on a design does not mean that those extra costs for those random moment connections, dropped arches, dropped beams, don't make it so expensive that it's not accretive to move the project along. So they got to finesse it. They got to finesse what the architect wants, and they got to make sure that building isn't going to settle differential. It gets a little more complex than just a normal mathematical equation, am I right? Structural engineers also responsible for selecting the material systems of that building. And that's a critical decision, I'll tell you why. If we have tariffs on steel coming out of a country, let's say now Canada or China, the cost went up. So is it more accretive to use a different material that's local, right? So the point being is they now have to have an understanding of the different materials and the impacts of the cost on those materials, right? So now, concrete, what's that great for? Great for mass, stiffness, and the fire resistance, right? Because in high density urban areas, we have massive fire codes. We can't allow fire to spread. Concrete is amazing at that because it's a non-combustible material. How about steel? Where do we see steel? Long spans, right? Because we can create these trusses, which are these massive sort of webs in our beams in order to span huge distances to have less columns, right? Where would you want that? Retail, at an arena, a theater, right? And how about this? Speed of construction. You get shop drawings for steel and they get manufactured elsewhere, so it should be like Legos and an erector set. Is it always like that? No, but it should be. And it's flexibility. You can change different shapes of steel that still have structural components to it. What else? Then we got light gauge framing. You're not going so high. So you want light gauge. What's light gauge? It's cold rolled steel. It's manufactured steel. It's not hot. It doesn't have to go through liquids into a liquid form and then get solidified. It's called cold rolled steel. Now that's good for mid-rise buildings, right? You're not going that tall. It's easy, it's lightweight, gets erected right in the field. And then last, we got this new, and we're seeing it all over New York and elsewhere in the Midwest, timber construction, increasingly popular for sustainability and aesthetics, right? Always looks fresh, it looks dope, but let me tell you something, more expensive. So this is the point. Each material has a different property. They're responsible for understanding the economics, what its capacity is for structural weight and its ability to carry specific loads, and its availability in that moment. So it gets a little bit more complicated. The structural engineer isn't just a mathematician. Now, what's another aspect of it that we don't really think about? Expertise in the field. Specific states, specific areas have specific crews that are used to specific materials. If a structural engineer designs something that can't be implemented in real time by a subcontractor, that was a waste of time in design. We see that all the time. When you have subcontractors that are working in wood and then you give them light gauge, that actually increases the cost because they don't understand what their waste is going to be or their ability to execute it. If you're in a place that's all steel and then you do want concrete subcontractors, will there be a market there? Will there be over demand? So a structural engineer has to understand the availability of the materials, the credibility of those crews in the field, and also achieve what the architectural design was looking for. So at the end of the day, it's always easy to think of structural engineers as math guys, math people, loading diagrams, stress testing calculations, but the best structural engineers out there also bring real-world experience and judgment. They know what works in the field. They can go out to the field, create a quick SK, and actually make a decision that does work. Obviously, I go back to the drawings and we got to refile it, but they're also in the field solving issues that actually occur. They understand the contractor's perspective, they understand the sequencing, they understand the budget. They can value engineer a project without ever compromising its safety. We deal with it all the time because, as we discussed earlier, if you have specific details that are so expensive it's not feasible to build, you're never getting that building out of the ground. Finally, and what's most important to everybody, where does it show up in our underwriting and our pro forma? Okay, so basically it shows up in two different ways. We talk about it a lot. The soft costs, right? Engineering fees. They got to cover the structural analysis, the construction drawings. How do you make an application to cost? Now, if it's a simple building, urban infill, not that tall, it's a price per square foot. But as you get more complex, post-tension, pre-tension, any type of high rises, it gets much more expensive. So we use a price per gross square foot. And then it's similar to what we think the MEP engineer is. So we make the application that in low density single family, it's much less, just a quick consulting fee. But in high rise construction, we're looking at anywhere from $200 to $350 a foot on gross square foot when we're underwriting our structural engineer. Now the second thing is, and it's much harder to tell, and it's not really the structural engineer's responsibility, but it is yours as a principal developer, and that is, what is the cost of the structure in the field? That's your hard cost. We'll get into that in another section of this in a much later date, but the structural engineer, his design impacts what your cost will be for superstructure in the field. So one misstep here, over designing, sets you back months and months because you're designing and you're coordinating drawings today, bidding them for a future that doesn't exist yet. So the structural engineer is much more important than just someone designing. They also impact the future costs of your project. Choose wisely, choose someone who has experience, and choose someone who actually knows how to get it done. Everyone on your team must be Machiavellian, which means the effective truth, the result of an action. Do they have the experience to to know that their design can actually get built within the geographic region that you are. One misstep, it'll be too expensive, and you're never getting it done. So next time when you walk into a building and you see some wide, expansive lobby with high ceilings, you know a lot more was put into it than just some math calculation. Or if you see some glass box suspended over the sidewalk in Midtown Manhattan, you know there was a lot more into it than making glass into a structural item. They work in their background. You never hear any press about them, but their decisions shape every square foot of the building you're trying to develop. Next time in our next episode, we're going to get into, I like to call it the organs of the building, the MEP engineer, mechanical, electrical, plumbing. They also do HVAC. I don't know why it's not in the name. I didn't do this, okay? Someone else did. I'm just spitting facts for you. So pay attention, sit down, wait up for the next episode. And at the end of the day, we do this to show you that we have an understanding of the construction and development process, especially in the way that you underwrite that deal so that we can find you the right capital to execute on it. Or maybe sometimes we'll be the developers with you. Talk to you soon. Peace, everybody. Episode 5, baby, breaking down the development pro forma with Brody. At the end of this, you're going to be able to underwrite any business plan for real estate assets anywhere in the country. Pay attention. On episode 5, what's the line item? MEP engineer. What does that even mean? Mechanical, electrical, plumbing engineers. They're responsible for everything that you don't see, you shouldn't see, but would immediately notice if it didn't work. Think HVAC in the middle of the summer. You'd be sweating, you'd be pissed off, you'd be pissed at that mechanical engineer. So what do? Mechanical systems, heating, ventilation, AC, we said it. Electrical systems, lighting, power, emergency, fire alarms, plumbing systems, potable water, wastewater in, wastewater out, your vents. And also, don't forget fire protection. These people got to keep you safe too. Sprinkler systems, fire pumps, standpipes, water tanks. And that isn't all. Anything that has to do fire alarm, smoke evac, generator backups, that's the MEP engineer. So I always use this analogy when talking about the MEP engineer. You think the structural engineer is like the bones of a human, right? Keeping us standing upright. Well, the MEP engineer is all your vascular systems, your arteries, your heart, your pump, your lungs. That's their responsibility. That's the analogy that always made sense to me when thinking about who the MEP was. So here's something that people overlook about MEP. They're not just working inside your building and trying to design those systems. They also, depending on where your asset is, they need to connect to the existing city infrastructure. So now they're coordinating electrical service with your utilities, and NYC, that's Con Ed, and maybe National Grid on gas. They're filing the load letter, finding out the amount of power they can bring into your building, and then securing that approval. And that's something people don't realize. You need to be responsible for any type of rainwater that hits your building. So now they're dealing with the DEP and the local municipalities on your plumbing taps, your backflow prevention, any type of retention systems, and they got to deal with the stormwater management that I just said. So they're the ones who not only have to be able to design, and again, they also have to be politicians. That's why they're going to school and getting that PE. It's not so simple. At the end of the day, it's technical, it's bureaucratic, it's logistics, it's a process all at once. So the MEP engineer, they're right in the middle of it. They got to design and they're politicking like anyone else out there. The personality, the EQ still matters with that IQ. All right, let's break it down now. Great MEP design thinks about something that most of us don't. How does the air actually flow, right? So think about it. You got to design exhaust systems. If you got a kitchen and you don't have a good exhaust system, the entire building stinks. You smell it all the time when you walk in by any type of restaurant and you don't hear the right mechanical systems. You smell that food for miles, right? Think about your bathroom. You don't want to stink it for too long, especially if you got somebody coming over and it's the first time and it's a hot date. You got to get rid of that, right? What about your dryer exhaust? Did you know that dryers, when they don't have a ventilation system, your clothes don't really dry? Think about a lot of these electrical systems, these electrical dryers that aren't getting it done. But if you vented it, move a lot faster. And finally, that garbage room, you don't want to be smelling that from the 30th floor every time you got garbage, right? So they also have to supply fresh air. You didn't know, but there's a certain amount of fresh air. Otherwise, you get something called sick building syndrome. You got to drive fresh air into all of your common areas. So it's a balance. balance, right? Because it would be banging. You hear it in old pipes, right? You got to bring in new air. You got to get rid of stale air, comfort, compliance, constructability. They even need to know, which I think people don't forget, how do you route those ducts through the building so you don't even see it, right? You can't have noise. Can't have all these bump outs everywhere. They got to coordinate it within the ceiling without killing the aesthetic of what you're building. Designing a system is one thing, coordinating a system is another, and it's not just one system, it's multiple systems. You got to fit pipes, ducts, conduits through tiny ceiling voids, wall chases, mechanical rooms. And remember, these things run vertically, they run horizontally. Now think about it when you go into an electrical room, when you see these massive manifolds, then you see these thick pipes coming out of it. Everything has to fit perfectly. It has to fit into your architectural constraints. Now remember, we're driving these members through a deck, so now it's got to fit in with your structural members, and it has to be fully coordinated with the other disciplines that are there, including all of your architectural, your framework, your roofing, and everything else. And guess what? Most important, it's got to be hidden. The consumer should never know they exist. That's the magic of the appropriate MEP engineer. You never knew they were there. Right? Wasn't there something about the devil? The greatest trick that the devil ever pulled is that you didn't think they were there. Now, I'm not saying that's an analogy to MEP, but you shouldn't know they're there. Now, a great MEP engineer just doesn't think about your design. They're thinking about your install, your phasing, your accessibility, and the cost efficiency. They need to know if they can use copper or PEX, right? They need to know if you're allowed to use distribution in black iron or PVC. How to run ductwork above the ceiling versus exposed. How to minimize penetrations in any firewall assembly. The real value of a great MEP engineer is they're trying to solve all the problems before they've ever been built. And they save money by being smart about it, sequencing it, layout, simplicity, and installation. Is it constructible? So that's what's so important about these MEP engineers. And again, as I was stating throughout this whole thing, it's what keeps you alive, it keeps you breathing, and you shouldn't know that they're there. All right. Now, finally, as you know, we're talking about that development pro forma. So it comes down to where on the development pro forma is the MEP engineer? And once again, they show up in two places. You got your soft costs, literally your design costs. This is where you're paying the MEP engineer direct for the design, the coordination, the filing, the constructability, and any inspection. Although maybe you want to keep that separate. We'll talk about that later. Next is in the hard cost, right? If you're designing some new age VRF system versus a cooling tower and yet subcontractors in your area have no idea how to install it, you could do the dopest thing ever. You could do the newest thing ever. But if it can't be installed, and then how about this, serviced in the future, just adding costs that are unnecessary. So they need to understand about your market, about the big ticket items in that space. Can it get manufactured? How it gets installed? And if there's enough subcontractors in a market that you can actually price it to install it. You know, I'd say MEP on any job can account for 20 to 30% of your total construction cost, depending on the project type. So don't skimp, don't leave it to chance. You got to get an engineer that knows the process and knows the type of asset that you're building. So let's get down to brass tacks. How much you think it is? Is it 50 cents a foot? Nah, $1.50 to $2.50 and maybe going up depending on how much you want to spend on the right MEP engineer. And by the way, that's on a gross square foot, so pay attention. So when you walk into a perfectly ventilated room, you don't smell nothing, it's nice, it's cool, it's calm. Flip a switch, you take a shower, you hear a fire alarm go off, and your elevator's working, then you know the MEP engineer actually made that possible. And the best ones, as we said like the devil, you never knew they were there. So now, episode 6 coming up. But it's not coming up if you don't like, you don't subscribe, and you don't tell your friends about what we're doing here. This is the greatest free education out there. All that we ask is that you reach out to us for your real estate questions when it comes to development and it comes to finance, because that's the game we're in. We're giving this to you. This is karma, baby. Take it, run with it, and then call us for any of your additional questions. We'll see you out there in the field. Say what's up when you do. People have been coming up to me saying hello. I'm down, all right? If I don't smile, don't worry. The smile is coming. Peace.